Okay, so again, starting with 5.6, this is going to be all about application. There are going to be a lot of formulas that we see here, but again, if you've taken personal finance or you plan to take it, you will have seen these before or you will see them, okay? So we're going to go ahead and get started. Exponential growth is the very first formula that we're going to learn. Or not even learn, but use. You're not expected to memorize this. It will be on the formula sheet for the EOC, and it'll be on your test, so we'll give it to you on that. Okay, the big thing is you get the formula, but they're probably not going to tell you what A, R, and T, or A, R, and T are, okay? So that is something that you will have to memorize. So A is going to be your initial amount. R is going to be growth. And T is going to be time. That will be the same for all of them. So A is your initial amount, R is your growth, T is your time. So for this first example, it says the original value of an investment is $1,800. If the value has increased by 7% each year, write an exponential function to model the situation. Then find the value of the investment after 15 years. Okay, so you'll notice as I read through that problem, I underlined the things that I thought were going to be important. Okay. I need to just figure out what initial amount, growth, and time are and plug them into this. So first things first, what is time? 15. So f of 15 is going to equal, what's A going to be? Good. 1,800 is that initial amount. Parentheses 1 plus my growth, which is? Good. 0.07. Don't put the number 7. 7%, we've got to write that as a number, not a percent. Okay, so to write that as a number, it's 0.07. Close parenthesis, and we said time was 15. And I just typed that into my calculator just like that. 1,800, parentheses, 1 plus 0.07, close parentheses, to the 15 power. Tell me what you got. Is that what everyone got? Okay, cool. How would you label that if it's the value of an investment? Money sign. Cool. That's it. Okay, go ahead and try the second one. Good question. So for rounding, when it's having to do with money, I would do 2 decimal places, just because that's how we round money. Go. Okay, so when you read through this problem, in 2002, there were 972 students enrolled in Oakview High School. Since then, the number of students has increased by 1.5% each year. Write an exponential function to model the situation, and then find the number of students enrolled in 2014. Okay, so first things first, we've just got to write out the function. Okay, so we need f of t, but they did not tell us a time, did they? We've got to find it. How would we find it? Yep, 2014 minus 2002. We just need to know how many years have passed, and what is that going to be? 12. So f of 12 equals, what'd you put? 972. 1 plus what? Careful. 0.015. Good. Close parenthesis to the 12th power. Okay. And in this case, since we are telling a number of students, I would round up to a whole number. Okay. With money, we're going to round to 2 decimal places. But since we can't have like a half of a student, right, that doesn't really make sense. So we're going to round up to a whole number. So go ahead and tell me what you get for this. What'd you get? 5,200? Is that what everyone got? Let me see this.
No, I got 1162.
I did too.
Oh, you did 0.15. So you got to do 0.015. Yep, that's not right. What'd you say you got, Trinity?
1162.
1162. See if you get that, Trinity.
Yeah.
Okay, good. 1,162 students, right? That's how we would label that. Good deal. Okay, so that is exponential growth. Now we're going to do exponential decay. It's going to work the exact same way, except for there's one minor difference. F of t is going to be, what'd you say, Trinity? It's going to be subtraction, yeah. 1 minus r to the t power. Okay, a, r, and t are still the exact same thing as what they were. So a is still your initial amount, r is still growth, t is still time. Okay, I want you to go ahead and try number 3. Okay, how'd you set this one up? Yep, f of 9 equals 12,000. Perfect. Raise your hand if you set that one up perfectly, just like that. Good deal. Okay, and then what do you get? $8,310.40. Is that what everyone got? Good deal. Okay, so we're going to go ahead and skip number 4, but one thing before we flip to the next page that I want to point out. When you get to your test and when you get to the EOC, here's the thing. They're not going to tell you, okay, they're going to tell you to set up an exponential function, but they're not going to tell you if it's growth or decay. You've got to know when to use each one. So the key words, for instance, in numbers 1 and 2, what do you think the key words were that told you to use the growth one?
Increase.
Increase, yeah. Value increased by 7% each year. Okay, same thing here. It used increase both times. What about in 3 and 4? Losing. We also see in number 4 the word depreciate. That means the same thing as losing. Okay, if a value depreciates, if a car depreciates on value, it's losing value. Okay, so make sure we see those keywords and we don't pick the wrong one. Good. Okay, compound interest. Compound interest. So this formula, A equals A equals P times 1 plus R over N, close parentheses, to the NT. Okay, so we see some new letters here that we have not seen yet. Okay, but we see some of them are the same, which is good. Less things to memorize. So R is still going to be growth. T is still going to be time. Okay, P is going to be what we call principal. Okay, principal is literally the exact same thing as the initial amount. Okay, so that is still going to be your initial amount, except for this time instead of the lowercase a, we're using the uppercase P. Okay, and then last but not least is the letter N, which this means the number of times this was compounded in a year. So we'll say yearly. So the number of times that your investment was compounded in 1 year. So, number 5. Laura deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? So again, I underlined all the things that I think are going to make a difference in this problem. Things I will need, okay? So now we just go ahead and we start plugging in what we know. We don't know what A is, okay, but we know that she's got $12,000 deposited, so that's what I'm going to call the principal. That's her initial amount, okay? Times 1 plus R is that growth rate. So again, we put that in a decimal, so 8% would be 0.08 divided by N, which means number of times compounded yearly. What do we think that would be? 4, because it says compounded quarterly, right? and quarter would mean 4 times a year, 4 quarters in a year. Close parentheses, and then I take it to the n times t power, so that is going to be the 4, because we said n was 4, times t, which is going to be 5 years. Okay? Before I type that in, here's what I want to do. I want to go ahead and simplify that power. So 12,000 times 1 plus 0.08 divided by 4, close parentheses, to the 4 times 5 power, 20th, okay? 17,800 and what? 31 point
But I said
37. Is that what everyone got? Okay. Good. My calculator should do that, so, okay. Good deal. Questions on that? All right, go ahead and try number 7. Okay, in an effort to save time, because it is a Wednesday, we're going to go ahead and get going on this one. So how'd you set up number 7? A equals, so what? Number 7. Yep. You guys did 6?
I just erased 6, so.
Okay, I'm going to do number 7. A equals 4,000, that's my initial investment.
Parentheses 1 plus 0.039 over 2. And then there's a 12 and a 2 because the 2 powers that you're multiplying together, so it's 24.
Yep, 2 times 12 is 24.
Yep.
Good. And whenever you type that in your calculator, what'd you get?
6,358 and 48 cents.
Perfect. Did you say 48 or 58?
50.
Okay, I thought I heard you wrong. It is 50. Okay, cool. Questions on that? Some of you guys did number 6. That's fine. Did number 6 make sense? Okay. So real quick, on number 9, though, it says compounded weekly. So how many times in a year would that be compounded? 52. 52 weeks in a year. Okay. So on number 9, write that, not T, that N would be 52. Okay, we're not going to solve that just to save time, though. But you might see that on the homework, so make sure you have it. Okay, cool. So continuous rates. This is our next one, okay? This is our continuously compound equation, okay? So we look here, A is the final amount, like it always is. P is still going to be principal. You see that we have that letter E coming back, okay? I told you that that one's used in real life scenarios, okay? This is one of those real life scenarios where we do use that base of E. And then we have R, which is going to be still your rate, and then T, which is your time, okay? So looking at number 1, Tim invested $4,000 at 3% interest compounded continuously. How much money will she, a girl named Tim, that's kind of funny, have after 4 years? Okay, cool. So we'll go ahead. A equals, it says he invested $4,000, so that's going to be my P. No one's mom's name is Tim, right? Okay, I was checking. I just have never heard that as a girl's name. I think it's a typo. Okay, 4,000. We then put the base of E, and then we do our rate times our time. What's our rate? 0.03 times our time, which is 4. So when you type this in, I think when you put in the letter E in your calculator, it brings up a parenthesis. So just make sure that's all in the parenthesis. So it calculates it, and tell me what you get on that. 4,000 E to the 0.03 times 4 power.
I don't have any.
You do have an E.
Oh, I don't.
4,509. Here today. We're all talking together. 4,509. Got it. And 99 cents. Cool. Questions on that?
How do you calculate for that again?
Pretty good investment, right? Invest $4,000 and in 4 years you got $500. Okay, I want you to go ahead and do number 2. Do it quickly, if you can. Okay, so this one is kind of tricky. It says a certain bacteria has an exponential growth rate, daily rate of 10%, and it's compounded continuously. Okay, that is one thing with this formula. They're going to tell you if it's continuous or not. Okay, so you'll know if you're supposed to use the continuous formula or if you're supposed to use the regular one. Okay, so 10% compounded continuously. If we start with 0.5 grams and provide unlimited resources, how much bacteria can we grow in 2 weeks? Okay, so here we go. We've got A equals 0.5, good, that's our initial amount, times e to the 0.10, right? Or just 0.1 is going to be that 10%. Okay, and then this one is kind of tricky. So compounded, the continuously compounded equation, I do want you to go up here and write this. It is in years. Okay, this is the only one. So again, guys, compound, it does have to be in years. Okay, so make sure we're clear on that. I know for a fact I'm not going to give you a continuously compound equation that's not in years on the test, and if I do, I'll make sure I tell you. But in this case, this one is kind of difficult because if I were to convert 2 weeks into a year, it's actually going to be a fraction or decimal, yeah. So 2 weeks, how many weeks are there in a year? 52, so 2 over 52. Right? That would be the equivalent of 2 weeks for a year. Okay, so I want you to go ahead and type this in. 0.038. Okay, I'm gonna double check you real quick. Yep, Drew, I think you're wrong. It is 0.501. Or 0.02 actually. Okay. That one was confusing, okay? The one on the test I don't believe is that confusing, and we'll make sure we do more examples if it is, okay? Moving on, last formula of today, okay? We got to get through this. All right, so this is what we call our half-life formula, okay? Again, not expected to memorize it, okay? We just have to know how to use it. So N of T is going to be the quantity of the substance remaining, so that's typically what we're solving for. N sub 0 is your initial amount, okay? So what you're starting with, T is the time, and then T with a sub of 1/2 just means the half-life of the substance, okay? Science thing, if you ever want to be like a biologist or something along those lines, you're probably going to be working with this formula. Okay, so an isotope, sorry, I'm not a science teacher, I butchered that. An isotope of cesium has a half-life of 30 years. If 1 gram of cesium-137 disintegrates over a period of 90 years, how many grams would remain? Okay, so big things here. Half-life of 30 years. 1 gram, that's going to be that initial amount, over a period of 90 years, how many grams remain? So we're solving for N of T, and in this case, T is going to be how much time has elapsed? 90. Okay, not the half-life, but the actual time. So N of 90 equals the initial quantity, which is 1.0 or just 1, times the number 1/2 in parentheses to the T over T sub 1/2 power, which is just going to be 90 over 30. So this is the same thing as just 1 times 1/2 to the, what's 90 divided by 30? 3. So literally it's just 1 times 1/2 to the 3rd power. Or just 1/2 to the 3rd power, because anything times 1 is itself.
It comes out as 1/8.
1/8? Okay. You got 1/2? It should be 1/8. Because 1/2 times 1/2 times 1/2 is going to be 1/8. Okay? You can also put it in decimal form, that's fine too. Okay? But it's going to be 1/8 of a gram. So wouldn't you say that this formula, it looks more confusing than it actually is? It actually ends up being a really simple problem. Okay? I want you to go ahead and do number 2. Okay, so this next one. Isotope has a half-life of 6 days. How long will it take for a 100-gram sample to decay that only has 5 grams left? Say what? Okay, so if we look at our formula, N of T is the quantity of the substance remaining. Do we know that yet? Didn't it tell us that there's 5 grams that are left? So 5 equals initial quantity of the substance was 100 times 1/2 times what? So we actually don't know what the time is, but we know it's T over 6 because the half-life is 6. Okay, so then we would just have to solve this equation, and we will do this one as a warm-up next class. Okay, actually finish it, and then we'll check it next class. Okay. Still have your homework though. There is Delta Math. I haven't published it yet, but I'm about to. And then your homework sheet. So go ahead and do all the ones that you can do.